Global Finance, Topic 6, Purchasing Power Parity, Copyright Lou Gaddis. In this topic, we're going to use purchasing power parity to forecast exchange rates and exchange rate appreciations using both the relative and absolute version of the purchasing power parity, also called PPP. We'll start with the law of one price. The law of one price in economics says that two goods must sell for the same price. For example, if there are a stock sold in two different exchanges, if they're not selling for the exact same price, you can buy it where the market is cheaper and sell it where it's expensive. So for an equilibrium price to be reached, they can only sell for one price. The act of buying it in one place and simultaneously selling it in another place to make up a short profit is called arbitrage. Purchasing power parity is the law of one price applied to exchange rates. So let's look at the model. Suppose a Coke sells for $2 in New York and 1¼ pounds in London. The PPP model says that the exchange rate has to be equal to exactly the ratio of those two prices. Say $2 over £1.25. So the pound would have to be selling for exactly $1.60. If the pound is not selling for $1.60, there's a possible arbitrage in buying Cokes where they're cheap and selling them where they're expensive. Let's just show you that at that exchange rate, there is no arbitrage in Coke. Again, you pay $2 for a Coke in New York, and you pay 1¼ pounds in London. If the exchange rate is this PPP equilibrium rate of $1.60 per pound, the Coke will cost exactly $2 in London also, and therefore there's no arbitrage. Now say the market price of the pound is only $1.50. Okay, not the PPP rate of $1.50. At that rate, that 125 pound Coke in London at $1.50 per pound would only cost $1.87.5 in London. And therefore there's arbitrage in Cokes. You could buy Cokes in London and sell them in New York. Now the actions of this arbitrage, in theory, would motivate, say, Americans to buy pounds, use the pounds to buy Cokes, and sell them in New York. And what would happen is it would bid up the price of the pound from $1.50 to this equilibrium of $1.60. So in effect, the PPP theoretical exchange rate is the exchange rate that ensures there's no arbitrage with respect to a traded good. In this case, we'd say that the market rate of the pound, $1.50, is too cheap relative to our PPP fundamental rate of $1.60. So what we can say is we believe that the pound is undervalued by 10 cents or 6.25%, the difference between 10 cents and the base of the PPP. So here's an example using another traded good that's widely available over the world, a Big Mac. Say a Big Mac is selling for 14.7 yuan in Beijing and $4 in New York. Could we use PPP to suggest whether the yuan is undervalued or overvalued? Well, what we would do is take the ratio. Since this is the market rate of the yuan is 645 yuan per dollar, let's calculate the PPP exchange rate in yuan per dollar. So we'll do yuan price of a Big Mac over a dollar price of a Big Mac. That exchange rate is 3.61 yuan per dollar. So that's my PPP exchange rate. Again, my market rate is 645 per dollar. Now, if the exchange rate were exactly 361, a Big Mac in Beijing would sell for exactly $4.07. That would eliminate any arbitrage. So let's see what we can say about the exchange rate? Well, this exchange rate here, yuan per dollar, that's the market price of the dollar quoted in yuan. So we can say, looking at these two prices, the market value of the dollar quoted in yuan seems to be overvalued. So I'd say the dollar is overvalued. Conversely, the yuan must be overvalued. Now there's a second way you could solve these types of problems. You could actually solve for the price of a Big Mac in Beijing in dollars. So I can take, say, my 14.7 yuan times the market price of the yuan, and what you would see is the Big Mac is actually selling for closer to $2 in Beijing. So in that case, the exchange rate, or the price of a Big Mac in Beijing, is too cheap, therefore the currency is undervalued. Oh, and I circled the wrong one there. Sorry about that. That should be undervalued. Remember, the dollar was overvalued here. The yuan is undervalued. So if you see that Big Macs are cheap in Beijing, according to PPP, it's because the exchange rate is too cheap. So let's go to the next slide. And this is a hamburger index from The Economist magazine. And what you see is the market price of the Big Mac is $4.07 in America. And in China, it is 14.7 yuan. And the market exchange rate was 6.45. If I take my 14.7 yuan at a market exchange rate of 6.45, you see that Big Macs in China would sell for $2.27, which implies that the currency is undervalued. We can then take the ratio of the 14.7 yuan over the $4 Big Mac in America and see that the PPP exchange rate is 360, which is what we did on the last slide. And then I can calculate that as a percentage, take 360 minus the market rate 645, then always repeat that second number in the denominator and get a percentage. And we can say that the yuan is 44% undervalued. And The Economist magazine regularly reports the Big Mac index for major currencies. So you can see that these were, here's China here at 44% undervalued. The most undervalued at this point looked like the Hong Kong dollar. And you had some overvalued currencies. The Brazilian real, Swedish kroner, Swiss franc, Norwegian kroner, for example, Danish kroner, Canadian dollar, and so on. Now, this may seem silly, but The Economist publishes this regularly because it's been shown to be a relatively good predictor of exchange rates over the long term. Now, you would think that this model wouldn't work. There's a lot of reasons why Big Macs might be cheap in China. Now, PPP basically states that the Big Mac is cheap because the currency is cheap. And what has to adjust is the currency. That's the PPP. But there could be many reasons why Big Macs are cheap in China. It could be a matter of low demand. Maybe there's different tastes in China. Could be a lower cost of production, cheaper wages. So there's many reasons why you'd expect that Big Macs might be cheap in China. However, this model consistently predicts the right direction of currency changes. Now, one big reason why there might be cheap in China is related to this low demand, and that has to do with they have low incomes. Therefore, they have probably lower demand for goods like Big Macs. And The Economist magazine has made adjustments for these. Now, here's a couple graphs here. This shows the price of a Big Mac, about $4 in America. Here are our undervalued currencies, and here are a plot of the overvalued currencies. And on the x-axis, we also have GDP per person. So you have China at around 12,000 GDP per person. Now what you notice in this graph, there seems to be a relationship between the PPP predicted exchange rate and incomes. It seems to undervalue lower income countries and overvalue higher income countries. And I think it's because of this demand from lower income countries. So the Economist magazine has made an adjustment. So here's our initial 44% undervalued yuan value based on the ratio of prices. If you simply make it a one adjustment for simply incomes, they then come to the conclusion that the currency is fairly priced. Now, when this was published, this is 2007, you can see that this adjustment made a big difference. You can see that, again, initial values, adjusted values, initial values, adjusted values. And based on this analysis, actually the most overvalued currency was the Brazilian real, which is one of the worst performing currencies of this year against the dollar. So that's the absolute version, or absolute PPP. It just simply says that the exchange rate has to be the ratio of the prices of a traded good, otherwise there'll be arbitrage. And if it doesn't, the exchange rate will adjust. Now there's a better version of PPP, and it doesn't rely on prices of, say, Big Macs or Cokes. And that is, you just take a basket of many goods. Say you get a basket of 10 goods in Japan and it costs 1,000 yen. That same basket of 10 goods, maybe it's a Coke and a latte and a Big Mac and some other things, costs $12. You can then just take the ratio of that basket of goods and use that. So you don't have to rely on just the market supply and demand for one particular good. So in this case, I say my PPP value of the yen per dollar is 83. Say the market price of the yen per dollar is 80. Looks like the market price of the dollar seems to be too cheap, or the dollar seems to be undervalued. In this case, I'd predict that the yen is overvalued. And again, to get percentages, if you say that the yen is overvalued, you want to know by how much. I know it's 83 minus 80. Right, since it's overvalued, the numerator has to be a positive number, and I'll just repeat over 80, and then you can get a percentage overvalued. Now, the version of the model that's used most is actually called relative PPP. And relative PPP takes it for granted that goods may have different prices in two countries, whether it's due to supply and demand or incomes or whatever, even measurement issues. There's going to be differences in goods. However, if the prices of goods in a particular country change, that would then possibly cause arbitrage. So what would have to happen is the exchange rate would have to offset the relative change in prices in two countries, so the relative prices would be unchanged. Okay, so I'll say that again. Relative PPP doesn't say that the price has to be exactly the same in both countries. There's going to be differences. However, if all prices change in one country versus another, say one country has higher inflation than the other, the exchange rate would have to offset the change in prices, so the relative price of goods is unchanged. So this is a model that says if inflation is higher in one country, their currency is going to fall. So again, think about it. If Brazil is, say, having higher inflation, that means their good prices are going up and their goods are getting more expensive. This model says their currency has to offset. So if their goods are, say, 10% more expensive, the currency has to fall by about 10%, so there'd be no change in relative prices. And the formula for this model is this: the exchange rate at time t for currency h over f. So sometimes I'll think of that as home or foreign currency, but you can just think of currency h over currency f. Right, the price of currency f quoted in currency h is equal to the initial exchange rate times relative inflation value. So now this is currency h over currency f. right? The H price of currency F, make sure it's H over F inflation. So here's the example I put down here. Say that the euro is selling for $1.20. That's a euro per dollar. So this is euro over dollar. And the relative PPP would predict that the exchange rate will change relative to these two inflation levels. So I'm going to take inflation in the dollar, say 3%. So I'll make that, since this dollar is up top, I'll make that 103. And inflation in euro is 101. And I get a new exchange rate, 120 times 103 over 101. Now the next slide has that. So again, the initial exchange rate, 120 per euro. So my dollar over euro inflation says that the exchange rate will go to 122. All right, so let's think about the big picture. What this is saying is the U.S. has 2% higher inflation than the euro. Or the euro has 1%, the euro has 2% less inflation. So what happened is the European goods on a relative basis just got 2% cheaper. PPP predicts that the exchange rate has to go up by about 2% to offset that change. So there's no change in the relative price of goods. Now if we're trying to predict the exchange rate over 2 years, and the annualized inflation for both years is 3% in the US, 1% in Europe, we can see the exchange rate go from 120 to 103 over 101 squared. The exchange rate go up by about another 2%, or about 4%. So the exchange rate would go from 120 now to 124 if the US had 2% higher inflation per year. If you're trying to forecast exchange rates for less than 1 year, we're just going to adjust the annualized inflation levels by, say, n, and we're going to just do monthly. We'll just do n over 12, so n is the number of months. So for example, you're trying to forecast the 6-month exchange rate. So we're doing 6 months. We have the 3% annualized inflation in the US, 1% in Eurozone. We'll just take 6/12, so 1.5% and 0.5% on the denominator, and you see the exchange rate will go up from 120 to 121, which is about a 1% change. So what's happening is there's a 2% change in relative prices over a year, so it's 1% relative change in prices over 6 months. So the euro is going to appreciate by about 1% to offset that change. So here are a couple questions. Suppose that the inflation in Canada is 5% and the annualized inflation in the US is 1%. So Canada has 4% higher inflation. The spot price of the exchange rate, CAD per dollar, is 102 CAD per 1 US dollar. First of all, we'll say, well, what currency should appreciate? Well, in this example, the US has lower inflation by around 4%. So what we'd expect is the dollar would appreciate because there's lower inflation. And the CAD would depreciate. So what's the expected spot price in a year? Well, we can use our formula. The spot price in 1 year is the initial exchange rate, 102 per dollar. Again, this is CAD per dollar exchange rate. And I'm going to do CAD over dollar inflation. And you see the exchange rate is going to go to 106. Now in this one you could have made a pretty good guesstimation, right? If you knew the dollar is going to devalue, the dollar is going to appreciate because they have lower inflation. The CAD is going to devalue, and the spot price, 102 per dollar, that's the price of the dollar, and you know the dollar is going to appreciate. You knew it had to be greater than 102, so you can also say I knew the answer had to be 106 and not 98. Now what's the exchange rate in 2 years? Just take 102 times the ratio of inflations and square it. And lastly, what would the exchange rate be in 9 months if the annualized inflations were 5 and 1? I'll just take my spot price and just get 9 months worth of inflation. Make sure that you apply the 9/12 to just the exchange rate, and you get 105. So this is how you'd use relative PPP to predict exchange rates. And this model has been shown to reliably predict the direction of exchange rates over the long run. Assuming there's no other changes, like say bankruptcies of a country or political upheavals, which would cause a shock to the exchange rate. Now here's a problem. It's a slightly different formulation. It takes our basic model that says E1 equals E0 times 1 plus I over 1 plus I, except we're going to divide both sides by E0. So now we have this equation, and we're going to give an interpretation of the new exchange rate at time t over the initial exchange rate. We can think of that as 1 plus the expected appreciation of currency F. Right? It's the new price over the old price, so it must be 1 plus the expected appreciation of currency F. So if we know that, we can answer a question like this. Suppose the U.S. inflation is 3%, and the Mexican inflation is 12%. What's the expected appreciation of the peso in 1 year? Well, you could do a guesstimate, right? Mexico has rough 9% higher inflation, so my guesstimate would be that the peso would fall by that difference, 9%. But it's not going to work exactly like that, so let's get the exact solution. Again, this left-hand side of the equation is 1 plus the expected appreciation. So 1 plus the appreciation of the peso is equal to now the ratio of inflation rates. Now here's the trick on this problem. Should I use dollar over peso or peso over dollar inflation rates? Well, to answer the question, 1 plus the expected appreciation of the peso, I want to do the price of a peso. So to represent the price of a peso, that would be dollar price of a peso. So I want to use dollar price of a peso, new over old. That'll tell me what happened to the price of the peso. Therefore, I would need dollar over peso inflation rates. So 1 plus the appreciation of the peso is the ratio of 103 over 112. Let's subtract 1 from both sides. This would be the appreciation of the peso, and that turns out to be D, negative 8.04. One more problem. Suppose the Hong Kong dollar is selling for $7.75 in the spot market, and the 1-year forecasted exchange rate is $7.89. So that's my ET. U.S. inflation is 3%. What's the expected inflation level in Hong Kong? Well, we can use our formula. E1 over E0 equals 1 plus I over 1 plus I. And we're given Hong Kong per dollar exchange rates. So we'll do Hong Kong over dollar inflation levels. So I'll take my new exchange rate over my old exchange rate. I'm going to solve this problem for Hong Kong inflation and then put in my dollar inflation. Solving for IH, what I would do here is I'd multiply both sides by 103, get rid of that, and then subtract 1. And my IH, inflation in Hong Kong, turns out to be 486. So in this topic we talked about absolute PPP and relative PPP. Absolute PPP says there's no arbitrage in traded goods among two countries. Therefore, the exchange rate has to reflect the ratio of the two good prices, therefore they sell for the exact same price in both countries. Relative PP says there may be differences in prices due to supply and demand factors. However, if the relative prices of one country change, in other words, a country has higher inflation than another, the exchange rate has to adjust or has to offset that change so that relative good prices are unchanged. So this is PPP.